math student and whatever else. And the biggest thing it comes down to is the amount of effort that you want to put in. So if you are sitting here resisting filling in your plan book with the homework for the day, and you're resisting getting out a piece of paper to take notes, and you're resisting doing your homework the night it's assigned, change classes. They're like, I'm genuinely just trying to sort, like, have you guys sort yourselves. If you don't want to do this, you're probably in the wrong class. And there's no shame in that. If you at this point in the school year, you're like, man, global culture is a lot more than I thought, man. Connections has my brain just stuck on things all night long. Like, I can't keep up with how fast this homework is. Switching back and forth. By the way, sorry, I've said that I will always write this up here. CC3. Sorry, please make sure you write that in your plan book. This is CC3 now. So if you have issues switching back and forth between books, things like that, and like you don't all have textbooks. We don't have enough yet. I'm getting frustrated that this is taking so long. But like if this stuff is becoming problematic for you, if you see your math count rising, if you aren't motivated to do your math revisions, like you might just be in the wrong class, and it's okay. We can change your schedule. Otherwise, I need to stop asking these questions. The whole, did you fill in your plan book? Do you have a piece of graph paper out for, like, I should not need to ask those questions to an advanced class. You want to see a class of kids that want to do math? Sitting here for my next period on my 9 8th graders, because there's only 9 of them because they're so far accelerated. My class of 9 8th graders, I could essentially hand them the stuff and sit back and do nothing. And know that they would be totally fine. For most of you, I can probably trust that. But I don't think all of you, because there's still some of you that aren't getting out your plan book when you come into a classroom. And that's every classroom every day. Once you fill in your plan book, what should your desk look like? Yeah, either your math binder out or a piece of graph paper out or something. What should be on that piece of graph paper? A header, right? Whatever's in your header. I'm not super particular, because I had to have this conversation with my morning math class. I might as well have it with you. What we do in class is the intro assignments. Are the intro assignments? What we do in class is your intro. I don't normally grade that, because I normally trust that people are on task and engaged with me, and if you're not, like I walk around and I'm like, hey. But if I need to, and as we get further in the year, I'm not all about like playing games. I mean, well, board games, love board games, but I'm not one for like playing like stupid games. I should not be having to come around for you to take notes. Right? If you aren't taking notes until you think you're going to get caught not taking notes, change classes. This course, where you're sitting right now, is for people that want to engage with the mathematics and want to move faster than your peers. It's okay if you don't want that. That's fine. Okay, so as we head into October, because once we get beyond discovery days, changing classes would be kind of annoying. So like if you're on the fence, if you're debating, do you really want to be in this class or not, like you got to pull that trigger soon. You got to make that decision. Because you staying in this course says you are in it to win it. Like you're going to put in the effort. You are in charge. It's nothing that I can do. And like that, you have the power. Sit down.
Won't you eventually find out, because we look through our binders through conferences and stuff?
Yeah, but I mean, how much you put on your notes paper kind of is dependent on you. Some people write more than others. Like I always wrote a lot because I like all the details down. Yeah, kind of. But so what I'm really saying, sorry if I didn't make this clear, is I can and I reserve the right to, and like I hate saying that like I'm your teacher, I can kind of do what I want, but like I can collect your notes. If we need to, I can just daily. I have friends that do this at their schools because they can't trust their kids to be on task unless there's points attached to it. He collects notes every day, checks did they do them, like there's maybe one question that he specifically checks the answer, did they write down the right thing, and then just gives it back the next day. What that looks like to me is a giant waste of time. It's a waste of my time grading stuff that I shouldn't need to grade, isn't really worth a grade. It's your practice to be ready for the stuff you're going to be asked to do on your own. And like it's for you. Taking notes is for your benefit.
I think, no, never mind. Wait, did we already do 4.1?
You started it last week. So here's what's up. 4.1.1 in the 8th grade book is a lesson we skipped. We dove into a little bit of the 7th grade chapter 4 stuff just because there was some stuff I wanted to cover there. today's chapter 4 is in the 8th grade book. Your homework is in the 8th grade book. And I love where we're headed. I'm not joking. These are the lessons where it gets really fun and really creative with the math. So part of the reason why I just had that little spiel is especially for today and the pattern analysis work we're about to do. Sorry. You have to want to engage with this because it's very easy to quickly kind of be like, well, I'm struggling, so I'll just sit here and wait for somebody to give me the answer. And that does not benefit your brain at all. So you need to be willing, like when I say, okay, you have 5 minutes, look at these 5 different pattern things to keep yourself on task and keep working that. Please stop with the pencil. Thank you, sir. You should want to engage in this. Now, I started showing some of these to my 8th graders, my high school math 2 class, and there's really complicated growing tile patterns. Love them. They absolutely love engaging with these because it's really simple to look at, but sometimes the pattern is actually quite complex. So you're going to need this resource paper today, but probably not right at the moment since we have a little bit of intro. So hopefully we'll have the homework down. 26, you don't know how to solve 26 unless you've already done circle work. So use the back of your book, look it up in the glossary or index or whatever. Depending on how you look it up, you might need to go to a math notes box. Depending on how you look it up, your formulas will just be right there. And if you still can't get it, let's talk about it tomorrow. But 26, you will probably need to use the back of your book for that one. Anyone feel like reading? Yeah, Quinn, go ahead. From here down through these questions.
I can only read because I need to practice.
It's perfect. Growth opportunity.
In lesson 4.1.1, we looked at 4 different ways of representing patterns and we begin to find connections between them. Throughout this chapter, you look for connections between and find efficient ways to move from one type of representation to another. Today we look for specific connections between
Geometric. That's a weird word to say.
Patterns and equations. As you work, keep these questions in mind. Can you see the growth in the group? How do you know your rule is correct? What does the representation tell you? What are the connections between these representations?
So when we talk about rules, there are all those 4 different ways, and there's probably more to represent it. We can do it with a table, a graph, talk about the pattern like with words. We can define a rule like with a mathematical expression that defines the rule. So when we look at these growing tile patterns, one of the things that I start with first is numbers. Right? If I'm a very number-based person. Actually, true story, my pledge name when I joined a fraternity was Numbers. That was my nickname through college, essentially. Just because I was always really good with numbers. I hate the people that are like, quick, do this math, and then it puts you on the spot. But I was that guy. So if I look at figure 1, 1, 2, 3, 4, 5, 6, there's 6 boxes. So somewhere I jot a 6. Because this helps my brain work. And then I look at figure 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I put a 10 somewhere. Actually, you might put these like down here, right below where it says that. I have 8, 9, 10, 11, 12, 13, 14. So initially, my gut, when I look at the numbers of things there, might tell me what? Yeah. Yep. We're growing by 4 each time. However, if I'm asked to draw figure 4, I need to not only know that it's going to have 18 boxes, like plus 4, like that seems to be the pattern, but how it's going to look. So the other thing I ask myself when I start looking at one of these, guys, we do these, like us math teachers, we practice these every time I'm like away at the WEC, the Worthington Education Center. Every time I'm there at those math meetings, we practice these because it is one of those ways to keep your brain engaging with like new things. So Mr. Kazmarek, the head of the math department, will throw these at us, ones that we haven't seen, because you can make infinitely many of these growing tile patterns. How's it going to look? I might need to go back to the start and say, well, I started with a 2x2 square and then 1 off of each corner. Then I ended up with a rectangle, 2 off each corner. A bigger rectangle, 3 off each corner. So with your team, and I'm probably just going to give you a bunch of time and let you work through the next like few of these. You do that for all 4 of these. Let's see how good you guys are. So all 4 patterns on here. Now hold up. So here's what I need you to be able to tell me, be able to do. Actually, I think it's pulled up right here. Okay, out here, you're going to have to be able to draw it. And I will warn you, especially with how wide this is getting, you might want to start your drawing as far to the right as possible. And then off to the side here, you should be able to create a rule. And what we know right now is this keeps adding 4, right? But how do I actually formalize that into a rule? Well, figure 1 had 6, right? So if I say that the figure number is really my x, well, how many would figure 0 have? And figure 0 is like when time started, right? Like when this thing started at 0, like when it was birthed, or whatever you want to say, at 0. There's always moment 0, right? Because that starts everything. But if we keep adding 4, how many would figure 0 have? Simon? Not 0, actually. 2. Because this had 6, this had 10, this had 14. This would have 2. Well, how would that look? Well, the middle seems to be changing, and the corner. I don't even necessarily know how that would look. So,
Nothing.
I don't want the answer, actually. I'm trying to get your brains wanting to, I'm trying to get you hungry, right? So if you're able to draw figure 2, wonderful, but then off to the side here, you want to be able to say the amount of, okay, so we actually call these like n for what number of figure we're talking about. We either call them n or x. So you want to be able to say, like, f of n, the figure at n, whether it's figure 1 or 2 or 3 or whatever, will have a certain amount of boxes. Well, I had 2 even when I was at figure 0. Okay, so I had something plus 2. But this something has to be how it's changing. So how do I use the variable n? The fact that I saw plus 4 every time, and this initial 2, all of those things get involved in that rule. So out here, actually go ahead and write rule, because that's what we're going to try to put in that column off to the side. If you can't figure out the rule, it's okay. Just try to do the drawings. Try to know how many would be in figure 4. I'm going to give you a good 4 minutes at least. I'm going to give you at least a minute to engage with each of these. I will walk through them. Please don't talk to me if you haven't talked to your team. I love you guys. I want to talk to you like all day long. Like literally, I would honest to God hang out with you guys outside of school. I was joking with my buddy Dave yesterday. I was like, oh, I should send out a notification that I'm going to go disc golf and see if any of my students want to come meet up. Like, no joke, I want to talk with you, but part of your math learning is talking with each other, figuring out how to do this as group problem solvers. So I would like for no one to talk to me unless your entire group is stuck. Okay? I'm going to give you potentially all the way till 9:15, or sorry, 10:15. Time warp. Take a few minutes to really engage with this. If you get done with all 4 of these, then stick up a hand and I can come check the work that you got. You done with all 4? Are you kidding? Did you listen to anything I was saying, or did you just work? Okay, so give your group a little bit of time to do this. If you want, and the problem is you don't have a textbook, so you can't totally work ahead on your own. Yeah, without giving things away as a group, I would just try to like let them have some time to figure it out and then engage with them and checking whether your solutions are correct and how they visualize it. Because they might visualize it in a different way than you. You guys might have the same answers, but like how my brain works and how your brain works is probably different, right? Like so, I love that you have that done. Next time, try to wait for the release of like, okay, let's all do this at the same time. I'm okay with working ahead, but I know some of what I said probably just kind of like went in one ear and out because you were thinking through the math. Have you talked with your group? With what?
I'm not a psychiatrist.
But no, you have plenty of time to talk with your group and and struggle through trying to figure out formulas there. The n is always the figure number. So if I'm going to use n in my formula, in my rule, it's always the figure number. Like figure 1, figure 2, not tile pattern, but so like here n is 1, n is 1, n is 1, n is 1. N is 2, n is 3, n is 4 for what you guys made, and we could keep going to like an n being 5 or n being 6. So that rule, hey, so real quick, sorry, just to explain why we're trying to make the rule, what if I asked you how many tiles do we need for figure 100? You don't want to draw that.
No.
Right? You probably do. Now, some of you might, because you like drawing. But the reason we create a rule is so then if I say, what about figure 1000? We don't need to draw it. Instead, we just use the rule. Braylon, don't show. You should be talking with your team after you sketch out these pictures. Check your math. What's the what? Really, F stands for function. But right now, you can think of it as like figure number n. Like at figure, whatever you plug in for n. So if n is 5, you're at figure 5. But we're trying to represent how many boxes we actually need. So that f of n is talking about how many boxes do we need. Oh, I don't have an answer. Well, I kind of have an answer for you for this. What if you break up figures like this? So I think most of us have figure 4 drawn for the top one. But what if we break them up, we look at two different parts? What if I look at the middle section as a rectangle that's growing on its own, and then the corner sections as growing on their own? So we could break things up differently. So I'll go ahead and help you guys with this one to try to like formalize rules. I think that's where we're getting stuck. Most of you have pictures that I come around. When we say f of n, this really stands for function. We're starting to write function rules. But what we're using it as is like, okay, how many boxes do I need? Right? How many tiles would I need to draw to make this? At figure 1, I needed 6. At figure 2, I needed 10. At figure 3, I needed... So our change factor, our growth, is 4. Right? We're going up by 4. We've already said that. So we put a 4. How many times do I go up by 4 is determined by what? What determines how many 4s I've added on?
From what the factor number is?
Yeah, from the figure number, right? What figure am I in? So 4 times the number of figures. Like if I'm in figure 3, I gotta add 4 3 times. But that doesn't get me the right amount of tiles, right? 4 times. Oh shoot. 4 times 1 is 4, but that has 6. 4 times 2 would be 8, but that is 10. 4 times 3 would be 12, but that is 14. Connor? Plus 2, which is your figure 0. Growth factor, right? That's our growth. And this we actually call our initial. Initial is not figure 1. It's figure 0. It's when it's born, right? When it starts, when it originates. Figure 1 is after 1 cycle, after 1 week, or whatever the 1 is. So try to create those rules for each other situation on your resource page. Quinn, I can tell you're not on task when you're drumming with your pencil. I don't have the right binder out. Another way we can visualize this is by shading. What is new in this figure compared to the one before? Well, those 4 out on the points. Right, what is new in this figure? Well, those 4 out on the points. So then, if I start to work backwards, what must have been new? These 4 out on the points. In tile pattern 2, how many were there in figure 0? Anyone know how many there were in tile pattern 2 for figure 0? 1, right? If the end corner, or the end points, or whatever you call them, are the new ones, my initial must be 1. So figure 0, my initial, right, is 1. When I go to formalize this, and guys, I'm not going to draw all the drawings up here, but like as I walked around, everyone's pretty much got it right. It's this plus 1 more on each end. But if I write the rule, what's my growth going by?
4.
4, right? I'm gaining 4 every time. 4 times n plus what?
1.
Plus the 1. Any questions on how I got that 4n plus 1?
What's the 1?
The 1 is the initial, or the how many extra are not involved in the growth. So notice, this 1 in the center doesn't change ever. Like, check it. These were added on in round 1. These got added on in round 2. These got added on in round 3. But that center box is never changing. Now, actually, if I go back and I look at tile pattern 1 just like this, if I try to look at what boxes would never change, well, how could I look at this being added on from that? Well, my center got larger, and then this added on, and this added on. My center rectangle got bigger, and then this added on, and this added on. So if I back it up down to figure 0, how would I draw figure 0 over here? We know there's 2 in it. Connor? Just 2 squares on top of each other, because those middle 2 here are what don't change. Yeah, so it's all how you look at it, right? How you visualize. You guys need more time for tile pattern 3? Okay, so here 4, 5, 6, 7. What? How many in this one? 11? 15. Ooh, interesting. So we did a plus. 4 again. Plus. 4 again. If I try to shade, I think these were new and this was new. These were new and this was new. So this one I will draw. How tall will the left side be in my next figure? 5 tall, right? Sorry, my smartboard's not quite lined up this morning. And then 2 across the middle, 2 across the middle, 2 across the middle. Okay, still 2 across the middle. And then what's the right side going to look like? 4 stacks of 3. Right, and that has 19, I'm guessing?
Yes.
So what's my rule there? Again, 4n, since my growth factor is still 4, I'm still adding 4. But if I back it down, how many would there be in the initial?
Like
3. What would the initial look like?
me.
Braylon?
There would be 3 blocks on top of each other. Wait, no, wrong one.
Careful.
Oh, okay. 3 blocks aside. Wait, I still know what it is. Don't mistake me. There are 3 blocks aside.
3 blocks just beside each other, right? Figure 0 down here. Who's confused? Because this is weird. This is a weird strategy or skill.
Right.
The hardest thing is determining what figure 0 looks like. And the way we do that is look at what, like, don't start at figure 1. Start at figure 2 and say what got added on. These guys are new and that guy's new. What got added on? These guys are new and that guy's new. So then if I go backwards in figure 1, what must have been added on? Oh, well, the right stack and the top 1, which means figure 0 only has these 3 left. Notice, like, these unshaded are what figure 1 was. It becomes figure 2 by adding those on. This is what figure 2 was. It becomes figure 3 by adding those on. So this is 4n plus 3, because my figure 0 would have just been 3. Questions? How do you visualize tile pattern 4? Can anyone tell me what they saw for, like, how it's changing? Braille?
Those blocks at the bottom. I don't know how to explain it.
Yeah, the blocks at the bottom,
They're getting added.
these got added on the first time, right? To go from 1 to 2. And then these got added on to go from 2 to 3. So then if I draw this again, well, I'm still going to have the original T. So here's my original, right? But then my last one also had these. Yeah, my smartboard is not lined up. And then this one needs to add another new 2 of these. So we had 5 and 7 and 9 and 11.
Yep.
So now our rule, this one changes things. What's our growth amount by? 2 times the amount of times we've done it plus 3, right? If I take now by bottom 2, maybe now we kind of have to look at it as the right 2. Like maybe this is actually just. Who said I'm confused? So if this is. Guys, if you understand this and you're talking, you're being extremely rude. Your classmates all don't understand it. Plus 2, plus 2, plus 2. Right? So we can see the pattern is a plus 2 pattern. So if I go backwards, that would have to be a minus 2. So I know that that has to be 3. The question is, what does it look like? If, now there's a lot of times multiple ways to do this. If I look at the growth as stacking on 1 on the left and the right side. Down here, down there, down there. Well, the only way to go backwards is just remove from the left and right side. But as I work my way up, I then run out and I end up with just those on the left and right. Well, if I remove those, I end up with just a 3 stack. So we're not certain that's how figure 0 looks, but that's our prediction, right? We can pretty safely say that figure 4 is going to look like this. So that's 2n plus, 3, because 3 in the initial round. Yeah, Mike?
Do you have negative figures?
Yes. It gets quite awkward depending on what the figure was. And then you can start to look at like negative spaces. Sometimes it doesn't make sense. We can do it, but it doesn't make sense. And other times it does make sense. Like if I went back in time, what would have happened? So if I right now start counting the rabbits, right?
And they all go.
And they're increasing population because, as the saying goes, like, you know, breed like bunnies or whatever. Like rabbits reproduce quickly. So if I start with 300, there has to be some stages back in time where there were less rabbits, and that could make sense. But if I start with 2, and then I try to look back in time, doesn't really make sense, right? Like, it all depends on where your 0 figure is. Simon?
Wait, so would negative things be like
Don't think too hard about that right now.
the shape but backwards?
No, we should not continue this conversation. It gets conceptually very complicated. Like the concept between going into negative figures gets really confusing. Hang on just a minute. So the only thing we didn't do really is do this as a table and a graph. Excuse me. So what we're doing, that's we're not graphing right now. We're showing the different figures. A graph would actually be with x, y axes. So if you wanted to put this in a graph and use x, y axes, what you would do is have like your y axis. Just please jot this down on your paper real quick. We're not going to like make a real one. The x axis would be your figure number. The y axis would be whatever you need, which in this case would be tiles. And then we would see it start somewhere and increase somehow. Right, so with what we've been seeing, we start somewhere and increase somehow. So for most of those, we were increasing by 4 every time. Right, for the last one, we were increasing by 2 every time. And then the table, just x, y.
Oh, there's stuff back here.
And x, y would just be like figure number and tiles. So guys, if you wanted to make a table, x, y, like T-chart, right? Table is just another word for T-chart. X and Y, figure numbers, and table. So, if you flip to the back, this is now in relation to 413, which is why you have homework in both lessons. So please realize that's why I wrote out what homework numbers you needed to do. And I will get it, I will get that over on the homework board. I just didn't have time this morning. I got hung up with some stuff. Mr. Smith and I are working on a grant, and that has a deadline of Friday. So we got a little busy this morning.
What's the grant?
To put in a disc golf course out behind Phoenix. Yeah, the Worthington Education Foundation has money that they give away every year, so we're going to see if that works. If it happens, it will then become a student project. We'll make it project-based learning. You guys will plan out the holes and everything. Yeah.
Would it be a 9-hole course?
Yes, it would only be 9. We could only fit 9. To try to do an 18 back there would just be bad. And like the money's like each basket's like $240. So
Don't we have a basket in the
yeah, but that one you can't leave outside. It'll rust. Yeah, you've got to bring it inside. So the baskets we're looking at don't rust. They have a 25-year rust guarantee. Oh, I need to check what problem we're actually looking at. I think we're just comparing back. Yeah, so I kind of wish I had not made this front back, but we will make this easy. So you guys, flip your resource page and find these tables. I, up on the screen, am going to go ahead and show this again. So when this is kind of like when I go rogue, we've already covered most of what we need to do right here. Sorry, I'm actually going to put that on the TV. And then down here, I'm going to fill this in with you guys. No, 1, 2, and 1, 3. What the heck? There we go. We already kind of did this, but let's do it formally. Now, I personally prefer vertical tables, but there's a reason why they're having you do horizontals here. We figured out this had 6, 10, 14, and then we predicted 18. We also then were able to backwards determine that that had 2. I am going to now extend this to, again, something that you will need for science. The way we normally actually talk about graphing. So yeah, I have 5 minutes left. I don't know why people are moving around, but I had 5 minutes. Please do not start backing up. Is in the form of linear graphs. Please write this down. Trust me. Don't just write down graphs. Don't just write down the formula I'm about to do. You want to have written down linear graphs, which means they're a straight line. They don't curve. They don't do weird things. It's a straight line. how we represent that is y, the output, equals mx, like m times x, plus b. Please write this down, guys. If you stick with me for the next 4 minutes, you will be way ahead, and your work will seem easy. If you zone out and you're like, oh, it's the end of class, la-di-da, like you're gonna hurt yourself. The m is actually called our slope, but what that means is growth. What is it growing by? And if you technically, hey, Braylon, come on. Can I see you after class, please? Because you're not representing positive 7th grade classroom behavioral choices. I don't care if you want to flip your pencil. Do it at an appropriate time. Do you have any of this written down? I doubt it by you avoiding my vision. So you have written down slope as growth. So you're not with me. And you're also making noise and you're causing distraction for me and you're wasting your classmates' time. I like you a lot, dude. I don't like the behaviors you're doing right now. Most of life comes down to impulse control. When you figure out impulse control, things will be a whole heck of a lot easier. B is technically known as your y-intercept. What that really means is our start value. Here's where a table makes this all easier. Start value, just when x equals 0. Because we said our tables are actually xy, right? So although it says figure number of tiles, we know that's really xy. Our growth is nothing more than this. And that becomes our m. Now the reason we use m is because it's a measure of slope, or measure of change, or measure of growth, or actually measure of, you could also do losing, right? You give away $10 every week or something like that. That's why we use the letter m. M normally throws kids for a loop, like why m? Also, it does not look like a number, so I like that it doesn't look like a number. But so our technical formula, if I use this form here, come on, my smartboard's goofed. Now instead of using the f of x or anything like that, that did not capture, but it went elsewhere, is y equals 4x plus 2. Here, y, same growth, right? We still had 4x. What was our plus?
1.
1, right? Here, tile pattern 3. Y equals 4x plus 4. Here was a different growth pattern, right? What were we growing by in tile pattern 4?
We're growing by 3.
I think 2, right?
Yeah, 2.
Because if I scroll down, it's the one that keeps bumping up.
It's 2, yeah.
So it's 2x plus, what did we start with? 3.
Mr. Hudson?
Yes.
Couldn't we get lost in the weeds and say that it's 5x?
No. Because that will not work out.
Increasing by 1. You're also increasing by...
But you don't increase by 2 every time. Or sorry, you don't increase by the 3. The 3 just stays the same. So this increases every step we take.
No,
right?
You also have the thing on the end. You also have...
We're talking about figure 4. We're talking about this. That's not due each time. That only adds 1 each time. So you shade what's changing. That's changing. It's easier if I visualize here. That and the what's new. Does that make sense? We're gonna do more work with this tomorrow, but that is all the head start you need to get to your homework. Please look up the needed formula for your homework. You can even Google it, but you need the formula for area of a circle. It's in your book. I want you guys to use your resources. Have a wonderful day, guys. Hey, somebody remind me we need to graph these tomorrow. Will somebody remind me we need to fix? Hey, don't lose this. Keep track of this. We're finishing this tomorrow. Do not lose this. Do not lose this page.